All right, so lesson 2.4, writing linear functions. All right. Yeah. When you play Monopoly, it's easy to calculate the rent of most properties by looking at the selling price, which is work with a linear function. If you recall from last lesson, we talked about slope-intercept form, so we're going to be writing all of our equations in slope-intercept form. So y equals mx plus b. So that should be, everything you do should be in that form. So all you need to do is find the slope m and the y-intercept b, and you can write your equations. So for example 1, here they give us a graph, and they want us to write the equation in slope-intercept form. So we're going to do this in 3 steps. First, we'll identify the y-intercept. Then we'll find the slope. For a reminder that, or if you remember, slope is the same as rise over run. And then we'll write the equation in the slope-intercept form. So for this problem here then, what is the y-intercept? Okay, all right, positive 1. So that means that b equals 1. Okay. Now, how do I find the slope then? Okay, rise over run. So that means that we have to, in this case, we're going to go down and then over. So how far down does it go? Okay, so it's negative 3 over 4. Okay, so there's our slope. That's the value of m. So then when I write the equation, we get y equals negative 3/4 x plus 1. Okay. And the one thing to always remember is that you might rise positively or rise negatively if it's going down, but you're always going to run to the right. Okay? All right, we never run to the left, we always run to the right. Keep the denominator positive. It's much easier that way. Okay? That was quick. Okay. So if you notice, there's 2 points on the line. The rise is the difference in the y-coordinates, and the run is the difference in the x-coordinates. So we have the slope formula that goes along with that. So slope is always defined as the change in y over the change in x. So we will take the y values and subtract them in the numerator, and the x values and subtract them in the denominator. Notice that there's a specific order to them also. You notice that they put, it's y2 minus y1 over x sub 2 minus x sub 1. Now, does it matter which way we do it? In a way it does, in a way it doesn't. You could do it as y sub 1 minus y sub 2 over x sub 1 minus x sub 2. That will work also. Okay? You'll get the same answer. The difference is that I always want to do it this way here. Why? No, it wouldn't be backwards necessarily. But why would this, using this one, be better than this one? Why, Caleb? You're still going to end up using, you could still possibly use negatives. The difference is what? Spencer? Nope, doesn't change the answer. The difference is that there's no way to get a negative in the denominator here. Okay? If we do it the top one, if we always use the second x-coordinate first, okay, we always want to use these first because then the denominator will always be positive, and I would much rather work with a positive number in the denominator. Then you never run into issues there. Okay. So basically what that means is whichever point has the larger x value, that should be the one that goes first. All right, so here they just want us to find the slope of the lines. So the slope is equal to y2 minus y sub 1 over x sub 2 minus x sub 1. All right. So here we've got negative 5 minus 1 over 2 minus negative 1. And I'm actually going to do this one both ways and show you that, yeah, you do get the same answer, but it's much easier if you have a positive in the denominator. Yep, because it's a minus here and that's a negative 1. So what do I get when I subtract a negative? Okay, we're adding. So we get, in the numerator, we have negative 6. Denominator, we have positive 3. So the slope is negative 2.
Why wouldn't you do minus negative 1?
I did do minus negative 1.
5 minus negative 1.
No, that's positive 1.
And negative 5 minus
Top y.
yeah, no, it says y2 minus y1.
Right, that would be negative 5 minus 1. Now, if we did it the other way, you still get the same answer. Oops. Okay. Still get the same answer, so we would have 1 minus negative 5 over negative 1 minus 2. So it's the same answer, it's just that in this case, the negative ends up in the denominator, and sometimes when it's in the denominator, we get confused, we don't like it there. All right, so it's much better if we keep it in the numerator. Okay? All right, so either way, we got the same slope. All right, let's look at letter B here. They give us 4 points. They want us to find the slope. So we're still going to use the same method. Now, does it matter which 2 points I use? No, it doesn't. It's totally up to you. All right? So I could use the first one and the last one.
What if it's not like a pattern?
Then it's not a line. Okay? These are all linear. Okay? So if you notice, the x values change by 4 and the y values change by 3. Hey, there's your slope right there. Except it's backwards. Okay? So it has to be that way. So if we take 11 minus 5, and if I use 11, I have to use 16. And if I use 5, I have to use 8. Right? But the nice thing about this is the denominator is always going to be positive. So 11 minus 5 is 6. 16 minus 8 is 8. So we get 3/4, which, if you look at the points, that should make sense. Y changes by 3 each time. X changes by 4. There's my slope, 3/4. All right, so they want us to find the slope again with this graph. So for the graph, we need to find 2 points. All right, so let's see, 2 points. Oh, we have lots of choices, don't we? All right, Mr. Greca, what's one of the points on that line? Yep. On the line, yes.
Negative 2, 3. Down 2 over 2.
Okay. That would be probably, you mean negative 3, negative 2? Okay. All right, so he's got this point right here. All right, which is negative 3, negative 2. All right. John, how about another point on that line? 0, negative 2. Okay. All right, so we've got the y's, negative 2 minus negative 2, over the x's, which would be 0 minus negative 3. So what's negative 2 plus 2? 0. So we get 0 over 3, which is 0. Okay. Can you conclude anything from that? Okay. If you have a horizontal line, the slope is 0. What if I had a vertical line? Yeah, vertical line, it's undefined because there's no change in the x, and you can't divide by 0. Okay? Because the slope of a line is constant, it's possible to use any point on the line and the slope of the line to write the equation of the line in point-slope form. So if I know a point and the slope, then I can use the point-slope form to write the equation of a line, and then I will finalize my answer in slope-intercept form. So here's the formula for point-slope form. So if you have a point and the slope, we'll put the point, the value of x will go in for x sub 1. The value of y sub 1 will go in here, y sub 1. And then we'll put the slope in for m, and then simplify it. So in slope-intercept form, they want us to write the equation line that contains the points in the table. So to use the point-slope form, we have to find the slope and a point. So first of all, let's find the slope of this line. So m equals, and I'm going to use the first one and the last one. 1 minus negative 5, change in y, over 8 minus negative 8, change in x. So 1 plus 5 is 6, and 8 plus 8 is 16. So we get a slope of 3/8. Okay. Now, to use point-slope form then, not only do we need the slope of 3/8, but we need to use one of the points. Does it matter which point I use? No. Okay. Absolutely not. But when you look at those groups of points, which one of them would be the easiest one to use? Okay, all right. 8 and 1. You and Gibson agree, huh?
Yeah.
Right. Why would 8 and 1 be better than negative 4, negative 3.5? Okay, we don't want to work with decimals if I don't have to. Okay, and why not negative 8 and negative 5? Okay, all right, because we got the negative number. So we always want to find the point that's going to be the easiest. In this case, whole numbers are always the easiest to work with. So we'll put in 1 for y and 8 for x. And then we have to write our final answer in slope-intercept form. So that means then after we write it here, then we have to solve for y. All right, so the first thing I'm going to do is what if I'm going to solve for y? Okay, we want to get it by itself, but I want to get rid of the parentheses here first. So it doesn't matter whether I add 1 first or whether I, okay, really it doesn't matter. Okay, but I'm going to get rid of the parentheses first anyways. So we get y minus 1 equals 3/8 x minus and 3/8 times negative 8 is what? Negative 3, that's right. Okay, negative 3. Negative 3. Okay. Because when I multiply them, the 8s will cancel, and then we get negative 3. So then we add 1 to both sides, and we get y equals 3/8 x minus 2. And that would be the equation of the line that goes to those points. Now, how could I check to make sure that that's right? Okay. I could graph this line and check any of the points to see if they're on the line, or I could just pick another one of the points, put it in for x and y, and see if it was a true statement. Okay? You actually have the option of doing that then for checking it. Okay? All right?